The SLC-2 Radar is a Chinese active electronically scanned array counter-battery radar designed to locate hostile artillery, rocket and ground-to-ground missile launchers immediately after firing, and to support friendly artillery by guiding counter-battery fire. SLC-2 radar can also be applied in adjusting firing of friendly weapons or rockets. With slight modification to software parameters, the radar can also be used to detect and track low-flying targets such as light aircraft, helicopters and RPVs. SLC-2 systems have sometimes been mounted on a Dongfang EQ2102 3.5-ton truck. Development, 4 and TPQ-37 Firefinder radar were sold to China, and these became the foundation of SLC-2 radar development. Aside from political reasons, the $10 million plus unit price tag of TPQ-37 was simply too costly for Chinese. The decision was made to develop a domestic equivalent after mastering the technologies of TPQ-37. After the initial test of TPQ-37 in Tangshan range near Nanjing in 1988, and in Shanhua district in October of the same year, several shortcomings of TPQ-37 were discovered and further intensive tests were conducted and completed in 1994. The requirement of the Chinese domestic equivalent was subsequently modified to address these issues revealed in trials. Due to the limitation of the Chinese industrial capability at the time, decision was made to develop the Chinese domestic equivalent in several steps. The first step was to develop a smaller one, which would result in the Chinese equivalent of an TPQ-36 Firefinder radar, and based on the experience gained from this program, a more capable larger version in the same class of an TPQ-37 Firefinder radar would be developed, which eventually resulted in SLC-2 series, Type 373 radar. This is the predecessor of SLC-2 radar, using older passive electronically scanned array technology. Type 373 radar is fielded after the Type 704 radar series, which Type 373 radar is based on. Type 373 radar is designed to specifically improve the performance of TPQ-37 by solving the shortcoming revealed in tests. One of limitations of TPQ-37 revealed in tests was that it was less effective against projectiles with flat trajectory, so it is much more effective against howitzer and mortar rounds than rounds from 130 mm towed field gun M1954 and its Chinese derivative Type 59-1. Type 373 radar is designed to improve the capability against rounds with flat trajectory. Another problem revealed in the tests was that the reliability of TPQ-37 is much lower than what was claimed. The reason was that when TPQ-37 was deployed in environments with high humidity and high level of rainfall, high salinity, high altitude, and subjected to daily high temperature differences, malfunctions occurs more frequently. Type 373 radar was designed specifically to improve the reliability against these harsh environmental factors. SLC-2, as Chinese capability in microelectronics matured, an updated version of passive phased array Type 373 radar is developed, designated as SLC-2. This is a fully solid-state, highly digitized version that adopts planar active phased array antenna. One of the shortcomings of TPQ-37 revealed in tests was in its multi-targeting capability. When enemy artillery batteries located more than 200 meters apart fires simultaneously, TPQ-37 could provide accurate coordinate for distance, but coordinates for positions were less accurate. accurate. This would not be a problem for most users because TPQ-37 can be used in pairs in conjunction, provide accurate coordinates for locations. However, these costly radars could not be purchased in large numbers and China thus developed the capability for SLC-2 to provide accurate coordinates for both distance and position. Bangladesh bought 2 in 2012. Pakistan also operates significant number of SLC-2 radar. Specifications: S-band detection range for artillery 35 km, for rockets 50 km, accuracy 0.35% of range 35 meters, peak power 45 kilowatts, noise 3 decibels, clutter improvement factor 55 decibels. Other features: active phased array antenna with electronic scanning both in azimuth and elevation, sophisticated computer-controlled digital signal processing, comprehensive online or offline byte, automatic manual height correction with digital video map, various effective ECCM tracking while scanning.